Okay, so as we look at example 9.3, we're now going to be using standard shapes in building our composite areas. So if we look at the problem statement starts at the bottom of page 186, example 3 or 9.3. It just says find the centroid of the composite area of the structural shapes shown on the following page. So I'm going to turn over, and our composite area is going to be made up of this I-beam shape and the C channel turned on its end, kind of sitting on top. Okay, so our shape number 1, as they're identifying it, is going to be a standard shape that has an S10 by 25.4. And then the C channel call out is going to be a C8 by 11.5. Now, I've identified the pages that we find each one of these structural shapes on, and they are going to be found in the appendix section handout that I have attached in our learning plan. Okay, so I'm going to go to page, I'll start on page 463. Okay. So page 463, I'm going to go underneath. We're going to find this chart right here. And it has the shape of the I-beam. All right. And if I zoom in here on the left-hand side is where the designation call out is going to be. So it's an S10 by 25.4. So let's kind of look at what this designation, all these rows are calling out as. So the first row is going to be the area, the cross-sectional area in inches squared. Then you'll notice they have a dimension here called depth. Depth for an I-beam is going to be the overall height. Okay, so this dimension right here for our shape is 10 inches. Okay, that's what they call the depth, right? Web thickness. Okay, web thickness. The web is this right here, the width this way. That's between the eyes. So this is going to be our web. And then our flange thickness and width. So flange thickness is going to be this dimension here. So that's the flange. Flange thickness. And then flange width is going to be this way. Okay. So if we go down here, kind of thinking about those dimensions, our web thickness is 0.311, the thickness of the vertical portion here. Our flange width is going to be 4.661. Our flange thickness right here, 0.491. Okay. And then as we go over to the right, you're going to notice that we have a column for I. That's what we're going to find out the next time we're together. That's moment of inertia. S is going to be called what we call the section modulus. That'll be used in strength of materials. R is going to be your radius of gyration. That's a strength of materials thing as well. And then we've got another I, an S, and an R for the other axis. Okay. Now, as we look here, you're going to notice that there are two axes of symmetry. So the centroid of an I-beam is going to be at its geometric shape, or I'm sorry, geometric center. So to find the centroid of this, it's going to be 5 inches up from the bottom, and it's going to be exactly in the middle there. All right. So these are kind of easy to find. Okay. So that's going to be for our I-beam, our vertical member, shape number 1. And then we have our shape number 2, which is going to be our, what's referred to as a C channel. And that call out is a C8 by 11.5. So a little bit further at 467. Okay. Similar chart, but this time our shape is different. Okay. And our shape is sitting like this. So our I-beam is underneath here. Okay. Now I highlighted again our call out. This is a C8 by 11.5. Area is the first column. The depth is 8 inches. So notice that it's a C8, 8 inches is a depth. The depth in this case is going to be, again, the height. This is the depth. Okay. web thickness. The web thickness is 0.22. This is the web. It's the vertical as we see it here. That's the web thickness. The flange width. The flange width is going to be this right here over the longest dimension. And the flange thickness then, I don't know if I'm going to get it in there. It's going to be this part. Flange thickness. Okay. And then as we go to the right, it's going to be the I, the S, and the R. These are strength of materials things. Okay. That'll come up later on. All right. So these are our two shapes, and we're setting this, if you would, on top of our I-beam. Okay. Top of our I-beam. So kind of keeping those two pages handy, okay, or identified, those are going to be where we're going to collect the information about the area, the X's, and the Y's. Okay, so our process is going to be the same, but getting those values is going to be using the appendix. Okay, so first things first, we want to establish our reference axis, which has been established for us in our problem. So you'll notice that they have it coming down the middle, and it is at the centroid of our shape number 1. Okay, that's where it is. And sometimes you want to kind of strategically, if you have control over placing your reference axis, you want to do that because we're going to find out it makes things a little easier. Okay. So we have our reference axis, we've identified our shapes, and now what we want to do is we want to draw our structural shape in reference to the axis. Okay. So our first shape is going to be shape number 1. Okay. And we want to then just redraw this shape on this axis, and you can sketch it. It doesn't have to be perfect. So we can kind of see we've got an I-beam that's evenly spaced on either side. That looks something like this ish. Okay. Now, area, we're going to go back to our appendix. Okay, back to our appendix on page 463, and we're going to grab the area for this. So in this case, our area was 7.46 inches squared is at the top of that column. Okay, so 7.46 inches squared. And you don't have to, but I'm just going to put from page 463, okay, in the appendix. Now our X1. Now remember, this is going to be in reference to our reference axis. And we strategically placed our reference axis on the centroid of shape number 1. So our X bar is 0, and our Y bar is 0. Okay, because the centroid is right here on the axis. There is no distance offset from it, right? And that's why it's going to become handy even when we put it into our charts later on. Okay, any questions so far? Let's turn the page. So then this is going to be shape number 2. Okay, shape number 2. So we're now going to draw that C channel in its orientation and in reference to our reference axis. So again, our reference axis is here, right? So this is the centroid of our I-beam, and our C channel is sitting on top here like this. Okay, sitting on top like that. Area, let's get the area first. So going back to page 467. Okay. C8, 11.5. Our area is 3.38 inches squared. .38 inches squared. Okay. Now, the centroid. our centroid for this is actually going to be not on the part. It's going to be right about there. So that's going to be our C2. And now we've got to use our information from the illustration here. Okay. So notice that we have an X bar distance. Now it's X bar because their X axis, when it's sitting upright as a C, its X axis is horizontal. So our X bar dimension, we want to go from the very top to where its centroid is. Okay. So X bar, as we look at this chart, is on the very end. Okay. And it's 0.571, 0.571. Okay. So from the top, from up here to our centroid, this dimension is 0.571 inches. Okay. Now we need to know from our centroid of our reference axis, from our X axis here, how far up that is. You see how the Y, no, how the X2 is going to be 0 because it goes right through the center, right? Because we don't have an offset different distance left and right. But our Y value, we need this number right here. We need Y2. Y2. Okay. Now, to get Y2, we know that this is sitting on top of that I-beam, right? So from the centroid to the top of the I-beam, that distance is going to be half the overall height of that I-beam. Do you remember the overall height of this I-beam? It is 10, yes. So it's an S10. And remember that its depth, the dimension, which is the height, was a total of 10 inches. So from its centroid, this is going to be 5 inches up to the bottom of that C, right? So from, where can I do this? I'm going to do it on this side. From here to here, this is 5 inches. Okay, from there to there, it's 5 inches. That still doesn't help us. I've got from there to there, but I've got from the top of the piece to the 0.571. So if I go back here again, and when this is sitting like this, is there a dimension that goes from the centroid to the top of the part, or that'll help me? Do you see how the web thickness could help me? Oh, did somebody put it in there? The web, yes, Josh, you're right. So let me go back down here. We've got to do our web thickness. So I've got C8, 11.5, web thickness, 0.220, 0.220. So my dimension from here to here is 0.220. Okay. So to get Y2, I'm going to have to go up 5, right? 5, and I'll write this down. So it's going to be 5 inches plus 0.220 inches minus 0.571 inches. So we go up 5, up 0.220, and then back down 0.751. So our Y2 is going to be, here's my calculator. What do you guys get for that dimension? $4.65. Anybody else get that? I don't have it in front of me. 4.649 is what the book has. Yeah, so 4.65 inches. Let's put 49 just to have the extra place so that our numbers kind of match up. Okay. And if you leave it at the 0.5, it's going to be close enough for sure. All right. So now we've got our areas, we've got our X's and our Y's for each one of our shapes. We are ready to fill in our table of centroids. So go ahead and grab the area, the X, do your multiplication to get your A times X, get your Y, then your A times your Y for each one, and then do our sums in the appropriate places. So I'm gonna do 2 first, 3.38. This is 0. So once you have your table filled in, now you can go and do your X bar and your Y bar. Then once we have our X bar and our Y bar, just draw a quick little diagram for me, okay? In reference to your reference axis. So same process, but we just get our initial numbers, our areas, and then having to kind of figure out really that C channel, because it was sitting on its side. We had to, you know, kind of use some of the other columns to derive where that center would be for that individual piece. Okay. So did everybody get a Y bar of 1.45 and an X bar of 0? And you'll notice that in your chart, by putting the centroid on one of the centers of one of our simple shapes, kind of helped us fill in our chart a little bit more, right? When it's zeros, it kind of makes it a little easy to add things up and such. So yeah, so you can be strategic, if you would, about where to place those reference axes when you have the control, okay? So any questions on this one, the process? So, yeah, so that's how we do it. So you would be ready for the first 2 problems in our application problem set. Let's just take a peek over there really quickly. I'm gonna, and I'll put the problem back up in just a second. So, see, application problems, number 8, last application problems. So these first 2 you would be ready for, and this is referencing the page numbers in the chapter 9 here, okay? Well, I should say the problems in there. I'll put the page numbers. I notice I don't have them. So the first one you have is 910. So I'll go underneath. 910 is this problem right here. Okay, they identify the reference axis for you. You want to find the centroid of this composite shape. All right. And then you've got the hole here where there's material being taken away. So don't forget that that's a negative area. The other problem that you're going to do, just the centroid for, is going to be 918 right here. And you have two standard shapes. So the call out for the I-beam, a W10 by 22, and then that C channel again, C8 by 11.5. And you're going to find where the centroid is of this composite shape. Okay, so one with simple shapes, one with structural standard shapes. Okay, then the next time we're together, we're going to be looking at moments of inertia, kind of building on what we started here. So I am going to stop the recording